All right, today's topic is average rate of change and secant lines. Now, secant is not in the same context of secant as in the reciprocal of cosine. It has a different meaning in what we're going to be doing for today. All right, some background information. For a nonlinear graph whose slope changes at each point, the average rate of change between any 2 points, x1, f of x1, x2, f of x2, is the slope of the line through the 2 points. The line that passes through the 2 points is called the secant line. All right, this is just a variation of probably what you're comfortable with from Algebra 1. Instead of x1, y1, x2, y2 in your typical slope formula from your Algebra 1 book, we're using function notation. F of x1 just means the y coordinate that's associated with the first x value. All right, for our first example, it says find the average rate of change for the function f of x is equal to 2 sine of x over the interval pi over 6 to 3 pi over 2. All right, so they're giving us a graph here. We're not always going to have the luxury of having a graph, but we do for this particular problem. And the interval we're concerned with is an x value of pi over 6 to an x value of 3 pi over 2. Well, pi over 6 would be somewhere in this neighborhood right here. We can't get that value, or it doesn't appear as though we can get that value directly from the graph. 3 pi over 2 is over here. So it appears as though this is the endpoint for the interval that we're talking about. All right, if we didn't have the graph, what we would do, we would take that pi over 6. Actually, let's start with the 3 pi over 2 since we already think that that's a known value. We'd plug that in. We'd take the sine of 3 pi over 2. So probably the way most of you would do this would go to the unit circle, find 3 pi over 2. The sine is negative 1. Then 2 times the negative 1 is negative 2. So what it looks like on the graph is confirmed by our algebra. The right endpoint of this interval, f of 3 pi over 2, negative 2, giving us this endpoint right here. All right, we're going to plug in pi over 6 to get the y value for the left edge of our endpoint. So we plug that in here, sine of pi over 6, that's 1/2. 2 times 1/2 is 1. That makes the right endpoint pi over 6, 1. So it looks like we can get a pretty good, accurate location on this graph for that point. So right there, that's the point pi over 6, comma 1. Right there, that's the point 3 pi over 2, comma negative 2. Okay, the average rate of change is the slope of the line that passes through the 2 endpoints of the interval. So if we were to take those 2 endpoints, draw a line through them, the slope of that line represents the average rate of change of the graph. So back in your Algebra 1 days, it would be y2 minus y1 over x2 minus x1. In function notation, f of x2 minus f of x1. So negative 2 minus 1, negative 2 minus 1 is going to be negative 3. Okay, that's pretty clean in terms of the computation. Now we have to do x2 minus x1. 3 pi over 2 minus pi over 6. Well, depending on how comfortable you are with fractions and mental math, depends on what you'll need to do here. The thorough approach, give them a common denominator. Then you can subtract. We get a complex rational expression. One way we can deal with this is rewrite this horizontally. Negative 3 divided by 4 pi over 3. Showing the computation gets us to there. So the average rate of change of the function over that given interval is negative 9 over 4 pi. Okay, that average rate of change is also known as the slope of the secant line. Part of what you're being assessed on with this particular topic is understanding vocabulary. If it asks you to find the average rate of change, that means the same thing as finding the slope of the secant line. They're one and the same in terms of the numbers. All right, the follow-up question that's usually associated with this particular type of question would be writing the equation of the secant line. So that's writing the equation of that line right there. In this little corner of the math world we're in, which is pretty much a gateway to much of what you're going to do in calculus next year, the most common way that you're going to write the equation of a line is in point-slope form. Okay, point-slope form, you can see two different ways depending on what textbook you're looking at or what website you're reading. Y equals mx minus x1 plus y1, or sometimes they have that y1 on the left-hand side, like over here. Y minus y1 equals mx minus x1. Typically, most newer textbooks and websites that are geared more towards like a graphing calculator application will roll with this one here because the y is isolated. So if you're going to be doing anything with this on a graphing calculator, it's much more convenient to do that. This is a little bit more old school. So what you need to do is you are going to pick one of the two endpoints. It doesn't matter which one you choose. You can work with this one or you can work with that one. My personal preference, if I have the choice, I'm going to pick, oops, you couldn't see that circling, I apologize. You can choose this one or you can choose that one. They're both going to take you to the same place. I personally would choose this. Pi over 6, 1 is a simpler combination of numbers that has no negative signs. These numbers, slightly more stuff going on with a negative sign. So now what we're going to do is we are going to plug that pair of numbers with the slope we just found into this version right here is the one that I'm going to tend to use in class. So y equals the slope of the secant line, which is also known as the average rate of change. That x stays x. That x1 represents a point on the line or an x coordinate for a point on the line. That goes right there. There's my x1, y1, opposite of, same as. The other acceptable final answer would be to plug those two numbers in. Both of those equations produce the same line. They're going to graph the exact same way when you graph them. Most of the time, point-slope form is the most convenient, and once you hit this part of the world where we're venturing on the cusp between pre-calculus and calculus, it's the expected way to write the final answer. If for some reason you need it in slope-intercept form because of something else you're doing with it or because you're specifically told to use slope-intercept form, clear your parentheses, combine your like terms. It doesn't matter which of those two that you work off of, that gets it into slope-intercept form. If for whatever reason you need to get it into standard form, you would get this x term from the right all the way over to the left, multiply through by the common denominator in order to clear out the fractions, and that would be it in standard form. All right. It is expected that constants are kept exact. So that -9 over 4 pi, that 3 pi over 2, that pi over 6, we're not going to decimal approximations. Unless you are specifically told otherwise, there are no decimal approximations for these problems. All right, what this does is this begins the idea of, instead of an average rate of change and an equation of a secant line, once you're in calculus, it becomes the instantaneous rate of change, and the secant line becomes a tangent line. That uses stuff that's above and beyond the scope of our particular class. Average rate of change, secant lines, that's pre-calculus. Instantaneous rate of change, tangent lines, that's calculus. All right. Your assignment for today are the 8 problems. I don't know whether it's the other side of this page or a separate page. I don't know how that translated into Google Classroom, is to address these problems right here. So let's do number 2, just as an example from beginning to end. It says, write the equation of the secant line of, and it's giving us a function over the interval 1, 6. All right, what we need to do first is get the average rate of change. In order to get the average rate of change, we need the y values that go with each one of those x values. So we need to find f of 1. So the first step in this is going to be the cosine of 2 pi. That's going to be 1. So the left endpoint is 110. Okay, now we need to find f of 6 to get the y coordinate for the right end of our interval. So that's going to be 10 times the cosine of 2 pi over 6, which is 10 times the cosine of pi over 3. Go to your inner circle, pi over 3, cosine is a half. So the coordinates of our right endpoint, 6, 5. All right, the average rate of change, or the slope of the secant line, both those phrases mean the same thing, is going to be the slope of the line that passes through those 2 points. So 5 minus 10, y2 minus y1, 6 minus 1, negative 5 over 5, negative 1. So the average rate of change of that graph over that interval is going to be negative 1. That's also going to be the slope of our secant line. Now we're going to take that slope, one of those 2 points, and write an equation of a line. So y is equal to m, x minus x1 plus y1, or y is equal to negative 1, x minus 6 plus 5. If for some reason you need to get your final answer in the slope-intercept form, clear parentheses, combine like terms. I'm just going to do that to review the algebra here. If we did it with the first one, that'll be negative x plus 1 plus 10, y is equal to negative x plus 11. Or if we take that and put it in slope-intercept form, we get the same answer. If for some reason you need a final answer in standard form, take the x, put it all the way over, x plus y is equal to 11. So either one of those, you don't have to write both, would be the equation of the secant line in point-slope form, which is typically the way that you're going to answer these questions. If you have to get it into slope-intercept form, if you have to get it into standard form. Today's video going to give you a little idea of where this heads to from here. What I did is I took the function f of x is equal to 2 sine of x, and I graphed this in Geometry Sketchpad. I have the endpoint pi over 6, 1 as a fixed point here, which is A. I have B to where I can slide it to different locations. Let me see if I can get the coordinates of that up. So it's not going to allow me to get exact radian values here, but I know that the y value is solid. So the x value of 4.7, that's the approximation of 3 pi over 2, comma negative 2. So that line right there represents the secant line for the function f of x is equal to 2 sine of x over the interval pi over 6 to 3 pi over 2. Now, as I had just finished mentioning, this is in the domain of pre-calculus. What's going to happen in calculus is you're going to take that point and you're going to slide it increasingly closer to A until B actually lands on top of A. Once that B lands on top of A, you now have a tangent line as opposed to a secant line. In terms of slope, you now have an instantaneous rate of change instead of an average rate of change. So again, that's just a quick little visual there to give you an idea of where this topic heads from